Let's talk about one of the most controversial questions in science. Is our Earth round or flat? Let's start from zero. Our story begins in Greece over 2,000 years ago. Thinkers like Pythagoras gave an idea of a spherical Earth. But why? Was it a wild guess, or was there more to it? Pythagoras observed the moon and speculated that if the moon was round, then perhaps Earth was too. A simple but revolutionary thought. Now let's see what Aristotle has to say about this. Unlike Pythagoras, Aristotle provided the first physical evidence of a round Earth. He did it by observing lunar eclipses. He noticed that Earth cast a round shadow on the moon, a compelling clue pointing towards a spherical Earth. But let's not forget the contributions of the Egyptians. The Egyptians, known for their architectural marvels like the pyramids, were also very keen astronomers. They noticed that certain stars visible in Egypt were not visible in northern regions, suggesting a curved surface. So, the ancients weren't just making wild guesses. Their beliefs were rooted in observation and deduction, setting the stage for a debate that would span centuries. Let's see how our basic common sense has demonstrated that our Earth is not a flat disk, but a magnificent sphere. Consider that you're standing at the shore, gazing into the endless ocean. A ship sails away, slowly shrinking into the horizon. But does it just shrink and vanish? No. It appears to sink bit by bit, as if descending a gentle slope. Why? Because of the Earth's curvature. If the Earth were flat, the ship would simply become smaller and smaller to the eye, but never disappear bottom first. But the Earth's roundness isn't just visible at sea. Look up to the night sky. Did you know that the constellations you see depend on where you stand on Earth? In different latitudes, the stars are seen at different points, a phenomenon only possible on a spherical planet. And about the lunar eclipse. During these celestial events, Earth casts a shadow on the moon. This shadow is not a line or a square, it's always round, a perfect circle, no matter the angle. A flat Earth could never cast a consistently round shadow. But the most compelling evidence comes from beyond our atmosphere. The advent of space exploration has given us a perspective like never before. Satellite imagery and photos from space missions have shown us that our planet, viewed from space, is a sphere floating gracefully in the vastness of space. These images are not just pictures, they are testaments of human curiosity and ingenuity, a far-reaching gaze that transcends ancient beliefs and confirms what scientists have theorized for centuries. So, as we gather these pieces of evidence, the image becomes clear. Despite this evidence, there are those who challenge these truths. Let's explore the world of flat Earth theories and understand why, despite everything we know, there is still a debate. Now let's consider the most undeniable force that holds our universe together, gravity. This fundamental force not only binds us to Earth, but also reveals the true nature of our planet. Imagine a flat Earth. Gravity, which pulls everything towards the center, would create an unusual experience. If you walk towards the edge, gravity would pull you sideways, making it increasingly difficult to stand upright. Yet, in our world, no matter where we go, we stand upright, pulled directly towards the Earth's center, a reality only possible on a spherical planet. Now let's check out the very cycle of day and night and what it says about our planet's shape. On a spherical Earth, as it rotates, different parts of the planet are illuminated by the sun, creating day and night. This rotation also leads to the existence of time zones, each experiencing sunlight at different times. If Earth were flat, we would not have such distinct time zones. The sun would illuminate the entire surface uniformly. These are not just abstract concepts, they are realities we experience every day. The pull of gravity that keeps our feet on the ground, the sunrise and sunset that mark the passing of time, they all equate to the same truth. Our planet is a sphere. And yet, despite the clarity these physical laws provide, there are voices that challenge the spherical model of Earth. As we peel back the layers of these alternate theories, we begin to understand the complex web of belief, skepticism, and the human quest for understanding. In our journey to understand our planet, we now turn to a perspective that defies the conventional theories, the flat Earth theory. It's a view held by a small but vocal group in modern times, challenging the scientific consensus with unique interpretations of our world. Opponents of the flat Earth theory present a variety of arguments. They question the veracity of satellite images, suggesting they could be fabricated or altered. They also point to their interpretations of everyday observations. The way we see the horizon as a flat line, or how certain landmarks are visible at distances they believe should be impossible on a curved Earth. Some argue that water, being fluid, should not be able to adhere to a spinning ball, but should instead be flat and level. They also question the workings of gravity, proposing alternative explanations for why we don't fall off the Earth. But beyond these theories lies a deeper question. Why do some choose to believe in a flat Earth despite multiple evidences supporting a spherical planet? The answer is as complex as the human mind itself. Psychologists suggest that belief in flat Earth can be driven by a distrust in authority and a desire to question conventional wisdom. It's a form of skepticism, a way to challenge what is perceived as a blind acceptance of scientific doctrine. For some, it's about community and identity, finding a sense of belonging in a group that shares unconventional beliefs. This can be empowering, giving individuals a voice in a narrative dominated by mainstream science. Others find comfort in the simplicity of a flat Earth model, a straightforward explanation in a world where scientific explanations can seem complex. It's a yearning for a more understandable, more tangible world. Now let's expose these flat Earth claims with evidence and reason. One popular argument suggests that if the Earth were round, people and objects would fall off as they reach the sides or bottom. However, this fundamentally misunderstands gravity, a force that pulls everything towards the center of the Earth's mass. This means that down is always towards the center, keeping us firmly grounded, no matter where we stand on the planet. Another claim involves the appearance of the horizon. Flat Earth proponents argue that the horizon appears flat, not curved, but this is a matter of perspective. The Earth is so vast that its curvature is not easily visible at ground level. It's only from higher altitudes that the curvature becomes apparent, such as in an airplane or from space. Some also question why we can see certain distant objects, which they argue shouldn't be visible on a curved Earth. This phenomenon can often be explained by atmospheric refraction, which bends light around the curve of the Earth, extending our line of sight. Flat Earth proponents argue passionately. They claim the Earth is flat, motionless, and the center of the universe. This violates the views of modern astronomers, who maintain that Earth is a curved and spinning globe. In the world of astronomy, the flat Earth theory stands opposite to what we observe in the night sky. Astronomers point to the changing positions of constellations and the behavior of celestial bodies as evidence of a round Earth. But what happens when these opposing views collide in public forums? History tells us of debates like those between Samuel Roe Botham, a prominent flat Earth proponent, and Alfred Russel Wallace, a renowned scientist. In recent debates, a show featuring Professor Dave and flat earther David Weiss saw fiery exchanges over the shape of the Earth. Weiss argued that astronomical theories are flawed, while Professor Dave championed the scientific consensus. These debates and interviews, whether in past or present, aren't just about proving one side right or wrong. They represent a deeper quest for knowledge, a demonstration of how ideas are challenged and refined for public discourse. We're curious about your thoughts. Do you have any lingering questions? What are your views on the shape of the Earth? Let us know in the comments below. Now let's conduct some simple experiments at home to test the Earth's curvature for yourself. Here's something you can try. The Eratosthenes Experiment. All you need is a stick, a sunny day, and a bit of math. By measuring the shadow of a stick at noon in 2 different locations and calculating the angle of the shadow, you can estimate the Earth's circumference. Just like Eratosthenes did over 2,200 years ago. Or how about observing ships or tall structures over a large body of water? As they move away from you, notice how they seem to sink bottom first over the horizon, a visual cue of Earth's curvature. These experiments aren't just about proving a point. They're an invitation to engage with the world around you, to observe, question, and discover. Thank you for watching. Don't forget to subscribe and hit that bell icon.